We are developing a new generation of easily deployable 3-frequency radar, D3 MAN, for monitoring precipitation, cloud formation, and high-resolution wind fields, etc.
One of the main applications of the 3-band radar is the possibility to discriminate against non-meteorological targets, like for instance birds and also insects, which is very important for air traffic safety, but also distinguish between a different kind of precipitation like snow, ice fall, and different raindrop sizes. With this new radar system, we should be able to achieve this not only at a stationary place, but as it is mounted on a normal trailer, it can be deployed very easily to different locations. The main design is very flexible. It consists of 3 antennas looking into exactly the same direction with a precision of better than 0.2 degrees. And then the front-end electronics is optimized for the bands I mentioned. But everything below that, as well the radar waveform generators, as also the digital processing, is completely modular and can be replaced against other aspects and other ways of controlling this radar system. The pulse form used is also very flexible. It can be a standard pulse compression scheme, or it can be a pulse modulated part. The pulses are completely digitally generated and then also digitally decoded, which is easy to program to optimize the final resolution. The system itself consists of the pedestal with the antenna carrier and including all the front-end electronics, then a computer control system and pre-processing part, and then a further analyzing computing system with internet connection to make this data directly online available to, for instance, here the Finnish Meteorological Institute or other users who are interested in this part.
This radar development effort runs within a TECES-funded Clean MMEA program. That involves a good selection of research organizations in Finland and high-tech companies in the field of high-frequency research, extending up to tens of gigahertzes.
The companies involved here from the Finnish side are, besides Finnish Meteorological Institute as managing entity, then for the antennas, Ariel, Oy in Järvenpää, for the KU band front-end electronics, which is being built right now as a demonstrator, that the company Harp in Espoo, and the control and analyzing software, monitoring software is from Space Systems Finland in Espoo, and then the final analysis, which does also the combining of the data between the different bands, is made by Eigenor. We are in close cooperation with the University of Helsinki and also with universities in the United States.
Our scientific investigations and radar definition involves a highly tight cooperation with world-leading science organizations, in particular Professor Chandrasekhar and his research team at the Colorado State University in the US.
Areolo is established 1969, and today we are about 40 people working around antenna technology, and we also have a subsidiary located about 300 kilometers north from here, manufacturing accessories for our standard products. The main products are the reflector antennas, different kind of slotted waveguide antennas for radar purposes, and from the beginning of the company also tactical antennas for VHF and HF purposes. This is the first and the biggest antenna unit for solid-state radar system, consisting of 3 different frequency bands, and this particular unit is for Ku, diameter about 1.8 meter, and its special properties are very symmetric radiation patterns and low cross polarization, and also low side lobes. We have a far-field range which is about 1 kilometer long. The transmitter site is at water tower, and receiving end for recording purposes is located at our test mast top, about 30 meters from the ground. It's used for development process to get the pattern recorded and necessary adjustments made.
Systems Finland is a software development company who has started with space technology in creating software for satellites. For example, COMOS Envisat satellite was one of starting projects. From that, we have become a leading software development company in the space business, and we are involved in many satellites recently. For example, Helsinki and Planck satellites. For that, we made handling software. Our projects are, for example, Baby Colombo. For that, we have been making 6 and mix instrument software. Currently, we are building for instrument software for Meteosat third generation FCI and IRS instruments. That has just started. Space Systems Finland has been involved in a clean project from the beginning. In particular, we have been involved in developing this mobile 3-band radar. That is a new technology using solid-state components. In that, we are developing the control software for a whole radar. It will control the pedestal of a radar, the control of the generation of a signal, and receiving the data and the processing of the data also, even though the actual data processing of a radar is done by Eigenor. Here we have a simple test and development environment. It is basically developed fully in a Linux environment that is attached to one digital acquisition board here in the left that will receive the data from antenna. It will be also added an hardware box that will generate the waveforms for signal transmission.
Harp Technologies is a small company that is specialized in the development of RF and microwave technology. In this MMEA project, we are responsible for the development of a Ku band transmit and receiver module for the cloud radar. In general, we are specialized in microwave sensors, radars being active sensors, and radiometers being passive sensors, and we also develop different subsystems for such sensors. The history of the company started in 2007 when I founded it, and currently we are 4, let's say, seasoned professionals, and we have altogether maybe 70-75 years of accumulated experience. We have been involved in several ESA programs and projects. Also worked for various companies in Finland and within Europe, including large companies, but also very small companies. And yes, practically we help our customers to develop better products, but also we develop them instruments to acquire critical data, for example, from the environment.
I'd like